Greetings to all. This is Vaishnavi, Assistant Professor, IT Department from SNS College of Engineering. Now we are going to see about the CPU scheduling in operating systems. CPU scheduling. CPU scheduling is the process of deciding which process will own the CPU to use while another process is suspended. The main function of the CPU scheduling is to ensure that whenever the CPU remains idle, the OS has at least selected one of the processes available in the ready to use line. We have the 5 time, that is arrival time, completion time, burst time, turnaround time and the waiting time. First one, arrival time. Arrival time, that is the time at which the process arrives in the ready queue. Completion time, time at which the process completes its execution is called the completion time. Next one, burst time, time required by the process for the CPU executions. Next one, turnaround time. The time difference between the completion time and the arrival time is known as turnaround time. We have the formula, that is turnaround time is equal to completion time minus arrival time. Next one, waiting time, that is time difference between the turnaround time and the burst time. Here we have that formula, waiting time is equal to turnaround time minus burst time. Next one, CPU input output burst cycle. Here we have the diagrammatic representation. First one, load the store, add store, read from file, then wait for the input output. Next one, store increment index, write to the file. Next step, load the store, add store, read from the file. Then wait for the input output cycle. Next one, the process execution consists of the cycle of CPU execution and the input output wait. Process execution begins with the CPU burst. This is followed by an input output burst, then another CPU burst. CPU scheduler. The short-term scheduler selects from among the processes in the ready queue and allocates the CPU to one of them. Queue may be ordered in various ways. CPU scheduling decisions may take place when the processes switch from running to waiting state, switches from running to ready state, switches from waiting to ready state, then last one is terminates. Scheduling under 1 and 4 is non-primitive. All other scheduling is primitive, that is considered access to share the data, consider the presumption while in kernel mode, consider interrupts occurring during the crucial OS. Next one, dispatcher. Dispatcher module gives the control of the CPU to the process selected by the short-term scheduler. This involves switching the context, switching to user mode, jumping to the proper location in the user program to restart the program. Next one is dispatch latency, that is time it takes for the dispatcher to stop one processes and start another running processes is called the dispatch latencies. Next one, scheduling criteria. We have the 5 scheduling criteria, that is CPU utilization, throughput, turnaround time, waiting time and the response time. Scheduling criteria. Here we have CPU utilization. First one is CPU utilization, that keeps the CPU as busy as possible. The range may vary from 0 to 100%. Next scheduling criteria is throughput. Number of processes that complete their execution per time limit. For long processes, it may be 1 processor per hour. For short processes, throughput might be 10 processes per second. Third scheduling criteria is turnaround time. The time interval from the time of submission of a process to the time of completion is the turnaround time. Turnaround time is the sum of periods spend the waiting to get into the memory, waiting in the ready queue, execution on the CPU and doing input-output. Fourth one is waiting time. It is the sum of periods spent waiting in the ready queue. Fifth one is response time. Time from the submission of the request until the first response is produced. Amount of time it's taken to start responding but not to the output response. Thank you.